and do something with it, to analyze it, to look in those logs and find potential problems. But back in the days, there was no such service which could handle it on Azure, so they built it. So it has been built for the purpose of append-only logs in the beginning, at least. It has been purposely built also for high volume, high velocity, high variance data. Can be structured, semi-structured, or free text. High volume means we have customers ingesting probably around hundreds of terabytes each and every day into a single table, a relational table structure. High velocity, different data types, high variance comes with structured, semi-structured, or just JSON or just text. So we can cope with that. But still, it's a relational engine. So it comes with all of the goodies like joins, computed columns, filters, aggregates, stuff like that. It's a fully managed PaaS service on Azure, a vanilla database, so it can be used for various use cases. And one use case I'm going to go into details next time. This is IoT or industrial IoT. Me working out of Germany, I have a lot of contact with folks that are doing industrial IoT use cases. So I'm going to focus on that in the next session. It has been purposely built for those kinds of scenarios of append-only data streams. Purposely built, for example, we don't support transactions because usually with append-only data streams, something like that is not needed. So we did some trade-offs in the design of the database, which allows us on the other side to get more performance for ingestion and more performance for analytical queries. It has been built for interactive workloads. This is also something that I should probably mention in the beginning. It has not been built for batch workloads, at least not until now. We probably go into this direction later as well. So with Kusto, the queries can be arbitrarily complex, but what they can't be is they can't be executed for longer than 1 hour. So 1 hour is the timeout of each and every query. And interactive means that we would like to enable our customers to interactively use our service and get results in seconds or less than a second. So for ad hoc queries and not for long-running batch queries. The key pillars of ADX is the ability to do near real-time insights, to get near real-time insights on big data. That means is while the data is flowing into the service, you can get insights on it. So you can query the raw data, do some statistics, do some rough visualization, and then create your actual target data model as you like. But all of that is possible on a big volume of data that is being ingested. It's an optimized query engine for interactive query on log data. I think I already talked about that. It's a cloud platform for IoT, time series. As I said, we started with log and telemetry, but then we added some operators, especially the operators for time series analysis, where we enter a world of the vector-based analysis. So we're transitioning from the row-based analytics to vector-based analytics, and this is allowing us to execute some queries, some time series queries very efficiently on the data sets. And all of a sudden, we discovered that we are also a pretty good time series database. At IoT, just is pretty close to time series analysis. What makes us a good platform for IoT as well is our connection to or connectivity to existing service on Azure, like IoT Hub, or the plugin that has been released by the Azure Digital Twins team, which allows us to query other services like Azure Digital Twins from KQL. I'm going to talk about that later. Last but not least, automated scaling from gigabytes to petabytes. So customers can start small and scale out. It's an horizontally scalable database. Let's again start a little bit with some more history. Usually I just have to bring up those slides to show some weight. because usually our customers, at least outside of Microsoft, they don't really know Azure Data Explorer or Custo because it has not yet been that pushed that much by our marketing machinery. This is something that we are going to change. But yeah, our first customers internally after that initial Power BI story that I told you were Windows, Power BI, Office, Bing, and Azure itself. And meanwhile, we are in a situation where probably 99.9% of all Microsoft services, not just Azure or not just whatever, like all of them are ingesting the login telemetry data into Azure Data Explorer. As we realized as Microsoft that it's actually a great tool for internal purposes, some of the product groups decided to build their products on top of that database. Products that you know are application insights or log analytics. For quite some time, I've been an observability program manager because ADX was back in the days part of that product group and not part of Azure Data, which it is now. So whenever you create a log analytics workspace, you get a little piece of an Azure Data Explorer cluster. Same is for IoT service like time series insights or IoT Central. Okay, there are already some questions. I will answer them later. And also for the security stack like Sentinel, threat detection, and the gaming sector as well. At some point, again, this was successful as well. Sometimes more, sometimes less. But we thought if they are successful, why don't we want to offer this database to our external customers? So directly, not via as a higher level SaaS offering. And this is what we did in 2019, beginning of 2019. And on the right-hand side, you see our initial set of customers. Some of those you definitely know. I guess BASF, biggest chemical producer on this planet. Also Grab. Grab is the Uber of Southeast Asia. Bühler, that's company which is producing machines for that produce chocolate. Tabula, if you get annoying ads in the internet, it's probably them, and they send I don't know, tons and tons of data to Custo. And there's also a couple of security companies like Checkpoint and DocuSign, which send the logs of their devices to Custo and use it. Of course, we have a lot of others and also a couple of success stories. I can probably go over them later or not. Let's have a look at some of the numbers. The numbers are, in my opinion, outstanding. So for a service that is not that well known, we are dealing with roughly 85 petabytes of data ingested on a daily level. Customers are running more than 1 billion queries, so 1.3 billion queries per day. And overall, we're managing 6.6 exabyte of data in a relational, of course, multiple relational databases. All in all, the clusters are running on 2.4 million cores on Azure. And meanwhile, we have roughly 350,000 KQL developers out there. So for Microsoft, this technology is definitely key. And what we're trying to do now as a product group is also to bring this to our users outside of Microsoft, and we're seeing some tremendous growth. Questions to the part so far?
We have right now 2 questions. Okay. The first one is by Andreas, is how about sequences of DNA data, for example, instead of time series?
Probably that's possible as well, but it depends. If it's like append-only data, and there's some notion of time in it, which I don't think that is true for sequences. To me, I have never seen a customer doing sequencing of DNA in Custo. Usually what you always should have is at least some time component attached to it. So sequencing, I'm not sure if this is the right technology for it. But maybe I need to learn more about sequencing.
Okay, and then the next question would be Azure Monitor support.
So Azure Monitor is using this technology under the hood. So in terms of Azure Monitor support, what we enable our customers to do is to do a cross cluster query. So from an existing Azure Data Explorer cluster to an Azure Monitor workspace or Log Analytics workspace and back. What also some customers are doing, especially if they're interested in long-term retention of data from Azure Monitor or also from Azure Sentinel, they sometimes consider exporting the data from Azure Monitor to Azure Data Explorer because it's a little bit cheaper, but you also don't get all of the goodies of Azure Monitor.
Quick clarification, I didn't mean DNA sequencing. I mean sequences. Basically, if you would store sequences with just a sequence of data, basically, to then more efficiently search on patterns on this really long string, basically. Yeah.
Okay, bring the data, and we still have some time today. Why don't we ingest some? If you have some, I'm totally open to do it live with you.
I wish I
want Jason, I can do it.
I want to recruit some researchers who are working with this actually for that, but they're a little bit. They only want to use the old tools. But have the conversation later. Let's move on.
Okay, cool. And you will love the news that we are going to throw out in probably a couple of days. Okay, so what you should learn from this is it's a tool which has been battle proven inside of Microsoft. Meanwhile, also outside of Microsoft, it's growing rapidly. It's one of the fastest growing services on Azure. It's huge, it's big. So if you have some use cases that you would like to implement with it, go for it. Let's talk about some integration patterns. So integration patterns about the streaming ingestion. So you see here on the left-hand side, you have all sorts of data types, so logs, media, files, some business apps. Some of them are sending data to an Event Hub, IoT Hub, or Kafka. Others have the data integration with something that is called Azure Data Factory. Now, if Kustu comes into the picture, we can directly act as consumers to the streaming sources. So we can directly attach ourselves to an Event Hub, to an IoT Hub. We have a Kafka Confluent driver, which is pushing data to Azure Data Explorer. So those are the streaming sources. Okay, use cases, I can talk about this. So this means sometimes the architectures, they are shrinking a bit if Azure Data Explorer is being used. So you don't need to have any glue code between those sources. You can, but you don't have to. And you can push data directly to ADX. If the data is landed in ADX, you can push the data to a data lake. Sometimes that's a good idea for various reasons. Some of them might be that you want to do a training on, I don't know, 2 petabytes of data, and then probably you would run into that 1 hour timeout that I mentioned in the beginning. That's why putting it on a dump storage makes sometimes sense. Usually we see customers not doing that too often, but it's definitely an option. On the right-hand side, you also see that you can connect with various UIs, so visualization tools. As an example here is just Power BI. Power BI is a native connector to it. So connecting to ADX is super simple. The second case is you already have existing data on some sort of a storage account, and now you would like to ingest it either through Azure Data Factory or some sort of batch ingestion. You can do that as well. So both scenarios work at the same time. So you can do batch ingestion from a storage account, or you can do streaming ingestion. Batch ingestion is usually used for historical data upload. So if you have an existing system and you want to migrate. Okay, so what the heck is actually ADX? Now let's go a little bit deeper. If you're interested in use cases, I can probably talk about that later. I didn't integrate a slide on that. Probably I should have done that. Okay. Okay, maybe before we go into that, we can quickly just bring it up. Pretty sure I have something for you. Give me 1 second. Okay. So use cases that we sometimes implement by industry is it's quite diverse. So we see use cases from all kinds of different industries. I'm working a lot with automotive customers. I would say there's no automotive that is not using ADX. And one of the use cases that we see a lot, this is also reflected in our success stories, is getting telemetry data from cars. And so telemetry data from cars, it's a very, I wouldn't call it unique, but it's sometimes a bit of a challenging data that you can work with, because the schema for that data or the model for that data might be constantly changing, because from a canvas, for example, you get, I know, anything from a couple of hundred of signals to 10,000 signals. And you need to have a pretty relaxed data model in order to handle that. And ADX is able to do that, and still can process data very, very quickly and analyze it. And then on top of those telemetry storages or telemetry tables, people implement, or customers implement, something like fleet management on top. So there's a small fleet of trucks, I don't know, 50 trucks, and you want to know, where are my trucks? Are they leaving certain geofences? What are the KPIs of the drivers in that truck? Are they driving efficiently? And so on and so forth. So this is what they built then on top of this telemetry analytics. But at the same time, automotive is very interesting, because they also have a lot of production plants. And what we allow customers with is that they can store the data of their production plants, the telemetry, in an ADX. They can store the data of their cars, vehicles, in another ADX or in the same ADX, and then they can join the data from the production line and the actual vehicle telemetry that they collect from the cars. And then additionally, on top of that, is like after sales markets, where it's about demand forecasting. And all of that in a real-time manner. Security, we see, the classic things that also higher level service like Sentinel implement, but for us more on the lower level side. So if it's about storing vast amounts of data from some network appliances, we are customers implement that on top of Custo, and then do some security analysis on that. Oil and gas, those are scenarios where we are sometimes being used as the cloud historians, which means that we onboard data from all sorts of devices which are connected to some historians, and send the data to Azure Data Explorer, and then store the data and analyze in it. So it's mostly time series data. Also a bit of graph analysis, because all of these devices in those oil and gas and energy verticals, they're somehow connected, so connected assets, and you want to know which asset belongs to which in which hierarchy level, and then do analysis based on top of that. Advertising, that's pretty self-explanatory. Financial logs, audit logs, web analytics, and healthcare. And those are the verticals that we see the most. CDN is also very interesting. So content delivery networks. There was one, I think it was the Super Bowl, I think 2 years ago, where a big CDN provider in the States created a Custo cluster, or they always had a Custo cluster, but just for the Super Bowl, they scaled it out to 600 nodes to track the quality of their video streams for their customers, and find out if there are some problems in those streams. And then after the Super Bowl, they scaled it down. Those are some of the use cases. Okay, let's go back to this one and go a bit more into technology. Okay, there are some other questions. Use cases, we talked about that. Can we connect directly to Azure Data Explorer in ADLS? Yeah. I'm going to talk about this in this slide as well. So now we talked a bit about how big ADX is, what it can be used for, so some of the use cases, and now we dive in a little bit deeper on the technology side. So what this picture shows is actually the input and the output, and in the middle, the system that we're talking about. We're talking about Azure Data Explorer, and like most other big data systems in cloud environments, the first thing that it does is separating compute from storage in order to being able to individually scale out both systems. So in the compute layer, we have two virtual machine scale sets. Virtual machine scale set, that's just a template for scaling out virtual machines. And don't worry, you don't need to manage all of them. It's a PaaS service. You just consume an endpoint, and all of those nitty-gritty details are actually not so much interesting for you. You just want to use it and just sharing that information so that you know what it actually is. So two virtual machine scale set, one very small one. It's called a data management scale set, and it just makes sure that the connections to Event Hub and IoT Hub are intact and working. It's doing some pre-aggregation, pre-batching, and handling things like offsets, so which data has already been consumed. And the other one is equally important, if not more, but in this scale set, there's additionally some disks attached to it, to each and every node, which act as a cache. And this scale set is the engine virtual machine scale set. So whenever you query Azure Data Explorer, this is the part which is answering your query. I mentioned at the beginning, it's a distributed relational database. So this is one of the distributed portions. So that cluster can be scaled out horizontally and vertically whenever you like. And it can start with anything like 2 nodes, the minimum for a cluster. Okay, we have also 1 node set up, but that's just for dev test. So it starts with 2 nodes, and it can scale out until up to 1,000 nodes in a single cluster. Under the hood, so whenever you ingest data into Azure Data Explorer, all data is always stored on blob storages. It's not just a single blob storage, it's more than one blob storage, which we're using under the hood to store the data of our customers. It's 4, I think, and we do that because we need to have more bandwidth and a little bit more IOPS than what we get with a single one. This can also be scaled out horizontally. Now, if we want to query, for example, if you want to integrate data from the left-hand side, we have options to directly attach Kusto or Azure Data Explorer to IoT Hub or Event Hub, but we don't stop here. We also support open source tools like Kafka. We have a Confluent certified Kafka sync, and we have a Logstash plugin. Recently, we also did the Telegraph plugin. We support APIs in all languages. Well, not in all, but in, I would say, the major ones. And Data Factory, we also have a copy activity in there. And last but not least, of course, Spark. So for Spark, we created our own Kusto driver. And this allows you to, on the one hand side, get data frames out of Kusto, but also push data frames towards Kusto. On the right-hand side, you see all of the things, or a subset of them, which can consume data from Azure Data Explorer. So first and foremost, Power BI. Power BI has a native connector. It has an ADX user interface, including dashboards. Usually that's used for things like minimum valuable prototypes or data engineers that work with those dashboards. So we're continuously trying to improve them, but at the moment, I would say the focus is not the end customer. We support Power Automate and Flow, Azure Data Factory again to query data from Kusto, and then a portion of open source as well, like Jupyter Notebooks with something that's called KQL Magic, Grafana visualization, Redash, and others, and again Spark. I don't know if I already mentioned that, but we have our own query language. The query language is called Kusto Query Language. You find it everywhere on Azure. But if there's still some people who don't want to learn KQL, there might be one or two on this planet, and they can use our MSTTS endpoint, which is deployed with every Kusto cluster. So every Kusto cluster comes with an open port on 1433. You can connect to it, send your T-SQL to it, and you'll get back a proper result. This is needed for JDBC and ODBC clients. Okay, of course, everything can be managed through the portal or through ARM, so we have APIs there. Now to answer your question, can you connect directly to ADLS or from ADX to ADLS? Yes, you can do that. The concept is called an external table. So in our table structure in the schema, you can create internal tables, but also external tables. That external table can go either to storage account or ADLS Gen 2, and can also go to a SQL database. Especially on ADLS, it's important to if you, for example, have some parquet which is partitioned by, I don't know, year, month, day, you can also specify the partitioning on the storage account so that we efficiently query the blobs and that are needed to be queried. So the answer is yes, you can do that. Okay, things that I forgot. No. This is again talking a bit more about the ingestion to see which kind of tools or SDKs you can use. I mentioned already the major SDKs are, of course, .NET, .NET Core, Python, Go, Node.js, Java. The pipelines, the managed ingestion pipelines are Event Hub and IoT Hub. If you like to ingest data from a storage on a continuously basis, for example, you have a process which is creating a blob, sending it to a storage, and then you like ADX to insert it, you can do that. And the way that it works is that you create on the storage account an event grid trigger for blob created events. Those blob created events will be sent to an event hub. ADX is consuming from that event hub and then ingesting based on the blob created events, the blobs from the actual storage account. That's why we have event grid here. Plugins, I already mentioned Kafka, Spark, Logstash, and the tools to ingest data are one-click ingestion. That's a wizard-based ingestion, which I'm going to use today, I think, in one of the demos. And we also have other tools like Light Ingest. Light Ingest is a very small but super helpful tool to do historical backfills, where you have like years and years of data and you want to properly ingest into Kusto. So the data management part is handling all of those connections, doing some pre-batching, and then ingestion of that data. Now let's go a little bit more into the engine. Now that we know a little bit about the infrastructure, let's talk about the unique things of Kusto and why it's so great. Let's start from the bottom, from the top. Storage and compute isolated. It's about being able to scale them out independently. The next one is super important. It's doing compression and indexing and optimization under the hood. Compression means that we're storing the data. Our native storage format is called extends or data shards. And it's actually something like compressed column store. So a little bit like Parquet plus some more indexes. This is how you can think about it. This means that we are compressing the data automatically for you. So given that you have a use case where you want to ingest 1 terabyte of data each and every day, in average, our compression is 7, which is pretty pessimistic. And that means instead of paying for 1 terabyte each and every day for the storage that you consume, you will only pay for probably something like 140 gigabyte. This makes a huge difference in the long run. This is why also ADX is good for long-term storage of all sorts of domains. I already said indexing is part of that. So we index the data, we create secondary index for all elements in your schema. Yeah, the schema itself can be semi-structured or even unstructured, which means that you can create a table. That table can have various columns. Some of them can be, I don't know, an int, a string, a GUID, whatever. But there's one specific data type which is called dynamic, and that data type can be, for example, arrays, JSON, and we make it really simple to parse that data and work with it. The data is sharded, distributed, and cached across nodes and local SSDs. This is referring to the cache on the SSDs that I talked about in the architecture diagram. So all of the data that you like to cache resides on the virtual machine scale set of the engine on an SSD. So there's a quite good connection from the SSD to the actual CPU, which makes it super fast. The partitioning is crucial as well, because there's a default partitioning for all of your data. So if you ingest data into Azure Data Explorer, it's automatically partitioned by ingestion date. This is needed because we offer features like retention. So one way of deleting data out of Azure Data Explorer is defining a retention period. So you can say, I would like to keep all my data for, I don't know, 30 days or 365 days or 10 years. And after the data ages out of that retention period, because it's per default partitioned by ingestion date, and then we delete that data. Customers use this kind of feature for compliance reasons or for saving space on storage. On top of that, we can also manage hot and cold data. So cold data is everything considered on the underlying storage accounts. Hot data is everything that is cached on the virtual machine scale set disks. And those disks and this cache can be defined in so-called hot data days. So you can define the last X days to be hot, and then the last X days will be cached on the virtual machine. So if you're doing a query on a specific time period, time span, then if you're querying the hot data, it will be super fast. If you're querying the cold data, it will be a little bit slower. And if you're querying something in between, we take care that everything is handled properly. Is that ingestion date field supplied by the engine? When is it actually ingested, or is it supplied by the customer? No, ingestion time is automatically created by the engine. There's a policy to turn it on and off, but it's something that we automatically create. Besides the cache, besides the partitioning for ingestion date, you can also define your own partitioning. Again, useful for industrial IoT or IoT scenarios where you have a lot of devices and your query requires you to filter for a specific set of devices. And then what you would like to achieve with the additional partitioning is that the data for a certain device is not spread across multiple extents under the hood, so that you do less I/O during query time. So you can define, for example, if you have a schema of a device ID plus some time plus some I don't know, key and value pairs for that. You probably have a million devices. Then you can define a partition policy for the property of the device ID, and then we make sure that you get a little bit more data locality for the data of individual devices. So makes querying just faster. Table level caching and result set caching. Yeah, for quite some time we didn't have any result set caching. It was always, and the query was always re-executed and was still fast. Now we allow also server-side result caching. You can define the time period until it's evicted, and you can set it for each and every query. So if you send the same query string twice, you'll get the same result. Workload management, this tries to work around noisy neighbors that you have on your cluster, but there are various strategies on handling that. I'm going to talk about a specific one later. Partitioning, I covered. Materialized views, which is a super important feature. And especially if it's about time series and log and telemetry, you always get, for example, duplicates in your data, because either the source systems create them or some process in the middle had to be restarted and producing duplicated data. And then you need to find a way to deduplicate that, not to screw up your analytics that you do with it. Materialized views can help you there. Materialized views can also help you to downsample data and work on this. External tables I covered already. Questions on the engine part?
How much effort?
Sorry, we don't hear you.
I heard something like effort.
Could you please repeat the question? Okay, then we continue.
Okay. Yeah, feel free to send it to the chat and I can cover it later. Okay, now let's do actually something. So I thought as the first demo, we start slow and just provision the service. And then later on, we can query it. So now let me go and let's start here. I hope you can see my browser now. Let's go into the portal. So in the Azure portal, once it's ready, you're able to click on create a new resource. You search for Data Explorer, click on it, click on create. And then let's see. You need to, of course, select a resource group. Then you might want to select a resource group and a subscription. You give it a name. Let's call it Meetup in West Europe. I think Meetup is already taken, right? Oh no, it's not. Cool. And then you need to select the compute specification. So the compute specification is referring to the engine virtual machine scale set. You can select workloads from storage optimized, compute optimized, or heavy compute. I usually go to select from the list in my region. Depending on the availability of certain SKUs, you get different offerings, and you also won't get all the available virtual machine types. We're selecting those virtual machine types for ADX, and we don't support all of them. So you see you have D SKUs, E SKUs. At some point in some regions, you still might be able to find L SKUs. And here you can, for example, select the standard D11 V2. So that's a small cluster with 2 vCPUs, 14 gigabytes of memory, and 80 gigabytes of cache. I probably take this one. And then at the bottom, you can select the availability zones that you like those VMs to be deployed, and that's very important for high availability. Next thing is already scale. This is a very important feature. It's called optimized auto scale. So you can decide to have a cluster anywhere between 2 and 5 nodes, which means at least 2 nodes will be provisioned if it's needed because of CPU or missing CPU or too much CPU utilization or cache utilization. This cluster will automatically scale out the number of virtual machines. And if it's not needed any longer because there might be less CPU pressure or less data to be cached, it's also scaling back in. So the cluster is breathing based on a need. Now there's an existing mode right now, which is the reactive mode. So if there's, for example, you have some car telemetry hitting the data every morning, 5 o'clock, and the telemetry will hit the system, probably the latency will go up because it's not scaled out properly, and then it will scale out and then handle the load and back and later on scale it in again. But what you actually want to have is that it scales out before the load hits the system. So if you have some seasonality in all of that load, and our system is able to detect that, for example, a daily seasonality or a weekly seasonality, then the cluster will be able to scale out before the load hits the system and scale back in later. And this ultimately ends up in more customer satisfaction because all of the data will be nice and up to date. The queries will be fast as they like it. So I don't try to do something yourself. I would say rely on optimized autoscale. Couple of configuration that you can do here. We lately added auto stop of the cluster. So if you're not using the cluster, you might want to let the cluster auto stop, which is great to save cost. Usually it makes only sense in really rare cases because Kusto is typically used for streaming scenarios where you're connected to an event hub and then you have continuously events which need to be processed. So stopping the cluster makes no sense in those scenarios. Enable purge, you're able to turn it on and off. Purge is a feature which we created for GDPR regions, because if you really want to delete the data of a certain identity in your data set, then you need to make sure that all of the existing underlying extents need to be rewritten. And we take that super serious because we also need it for Microsoft purposes in order to be GDPR compliant. So with enabling purge, you're able to actually delete data. Streaming ingestion, that's a feature if our traditional way of ingesting, doing something like called micro batches, is not enough for you. So you need the data be available for querying in near real time, let's say in a sub-second level, then you can use streaming ingestion. Of course, this comes with a little bit more CPU cycles that you need. But in general, this allows you to go to a sub-second level ingestion. We can probably talk about that later. Security, of course, like we take all of the security topics super serious. We have a lot of sheet rooms on that on Azure, where we are tracked for compliance reasons, and we support a lot of that. So, of course, we support probably that will come later and during the configuration also encryption at rest with customer managed keys. We support double encryption of the underlying storage accounts. You can define tenants which are allowed to authenticate on the cluster. It's a multi-tenant database, so potentially you can get access to the cluster from a different tenant that you deploy the cluster in. That's very useful for ISV scenarios. It also allows you to give the cluster an identity, either a system managed identity or an identity that you used. Those identities can be used in order to authenticate on things like storage accounts or event hubs. So that you can provide proper role-based access to the identity of the cluster on an event hub or a storage account. Network, at the moment we support 2 modes. At the end of the month, we're going to support a new mode. The public endpoints means that you connect through the public URL of the cluster. And work with it like probably like 97% of all of our users are doing. If you don't like that and you need to have a little bit more network security, then you can decide to go for a VNet injection, which means you inject the compute, the virtual machine scale set into your own subnet, and then you get the responsibility to manage your own traffic, but also our traffic. Going to the direction of VNet and security probably requires us to have a dedicated session only on security. But I can do that. Diagnostics are very important to know about actually how your cluster is doing, and then you have tags and you can review and create. Now this is checking it. Let me just create it. Now what's now happening is it's creating a cluster. It will probably take, I don't know, 10 minutes because the virtual machines have to be created and deployed. We are continuously working on making that process a bit faster. At the moment, it still takes 10 minutes. While we are waiting for that, we can have a look at an existing cluster which I created upfront. It's called MeetUp Frankfurt. I'm very creative. You see, it has been deployed in that resource group. My little daughter is out there. It's in that subscription. Engine is not that much relevant for you. We lately had a switch from Engine v2 to Engine v3. So this is where this is relevant, but for newly created clusters, it's not. The state is running. You get two URIs, one for the query engine and one for ingestion. The compute specification is D11 v2, and there are two instances in that cluster. Now we can get the classic things like an activity log, access control, things that you should be aware of. We made a clear distinction between role-based access control on the Azure portal level and role-based access control on the data plane. So all of the roles that you set on the control plane, they're not reflected at all in the data plane, because usually the control plane, it's single tenant, and we wanted to make the data plane multi-tenant, and we hate guest accounts. So let's have a look at some of the others. So you can scale up the cluster. Right now it's a small one at D11. You can go up to bigger clusters. Probably you won't see that one in your subscription. That's for Microsoft internal only. And you also see that some of these SKUs, they have dedicated premium disks attached to it. Like this SKU, it has an additional 1 terabyte premium disk, which allows them to store more data in cache. Scale out. Again, manual scale, optimized auto scale, or custom auto scale. This one is scaled for 2 nodes. A couple of configuration things and a couple of other things. But let's don't worry about that for a moment. Let's go and query the data or do something here. So this is our own web experience. You can get to it by clicking on query. It will open something that's called the Kusto Web Explorer. If you click and open it in Web UI, you get the entire experience. You see, I already created a database. It's also very important for you to understand this, especially if you're designing solutions for ISVs. Is the database level is actually the authentication and authorization level on the data plane. So you can create up to 10,000 databases per cluster. And each and every of those databases can act as a tenant. So if you want to create a solution which should be like multi-tenant, then you can create for each and every of your customers a single database, and all of them can work on the on an ADX cluster, on a single ADX cluster. I think we're right now extending the limits from 10,000 databases to 100,000 per cluster. Of course, this makes like deployment more attractive because you're only paying for one infrastructure, and you can create 10,000 clusters on top of that. Okay, let's have a look at our data. I created a new database called February. You see, I already created a database, a table. So the hierarchy is cluster, database, table. On the table, you see that it has a couple of fields like start time, end time, the storm data from our help cluster, some other statistics, some latitudes and longitudes. Now, if you would like to ingest new data, just click right-click, ingest new data. You select the cluster, the database. Let's create a new table, call it storm. And super creative. Let's select the source. For the source types, you have several available. You can define a single blob, a file from your desktop, a blob container, an AWS Gen 2 container, or an event hub. I'm just going, don't worry about the noise. This is the usual alarm in my area when it's Wednesday. Okay, I need to get a SAS token real quick. Okay. I want to insert from a blob. I'm pasting in the SAS token. Now it's automatically generating the schema for me based on what I used. In this case, it detected that that the data has been compressed. It was a CSV, and it creates a mapping. Mapping means which column in the CSV is mapped to which property, to which column in the data model. You can also take a look at the command viewer that is created for you, and yeah, start working with it. Now the only thing that I need to do is click on Start Ingestion. By the way, the data types that we support is CSV, JSON, Parquet, Avro, and a couple of others that I always forget, but it's hard to find a format that is not supported. Okay, the data has already been ingested. Let's click on Take 10 to see what we get. And yeah, this is the output of this command. And what you see here on the right-hand side is KQL. For those who have never used it, it's beautiful and it's really, really elegant when it comes to time series analysis. So let's just write a couple of simple statements. The most important thing, if I'm typing something, I'm getting IntelliSense. Without IntelliSense, personally, I would be lost. So I'm really happy that we have IntelliSense in here. So I can select whatever I want. Then the next line, I get a pipe symbol. And then I can do like autocomplete and see what kind of operators I can do here. Let's do a simple count. You execute it using Shift Enter, or you can also be just somewhere in this statement and click the Run button. You see it's not that much, just 60,000. And now we can do simple things like, I don't know, let's do take 10. If we want to do something like a filter where, what is it? For example, state. Oh no, let's do event type equals tornado. Now we get all of the tornado events, and now I would like to find out in which states do those tornadoes happen the most. So I can do something like a summarize count. That's a group by statement of Gusto by state. Because I'm a human being, I like to see things. So we also have a render operator, which renders me things as a pie chart. And you see, okay, Texas gets most probably most of them, and so on and so forth. And now if I would like to take the same thing and do some lightweight time series operation, I can do by state and additionally group it by bin. So we bin a certain, I think they have something like a start time. And we bin it to 1 day. Let's try to render a time chart. I mean, it's not super beautiful, but what you get out of that is that probably here on, there was a peak in Kansas, like 45 tornadoes in May 2007. And there was also a peak here in Kentucky. And now we can do a lot more things. You can do geospatial queries and many more operators. Okay. Now what you've seen in this quick demo, how to okay, what is backing the rendering engine? Posted HTML or something else? I have to say I'm not a super expert in our rendering engines. I'm more in the in the security part and when it comes to geospatial queries, but yeah, we have our own web UI. What is backing that is probably just some couple of app services and Cosmos DBs to keep some data plus some application insights. So it's so the web UI itself, it's pretty simple. So is it generating HTML? Sorry, I don't know. I can probably follow up on those questions. Yeah, can you use it up? So because I'm not an HTML guy, sorry, I don't know anything about web development. I'm just using it. Sorry. Okay, can you do the same thing in Power BI? Excellent query. Excellent question. I did this in, I created a Power BI dashboard. And of course, you can use Gusto in Power BI. It has a native connector, so you can go to get data, take a look at more, search for Azure Data Explorer. Oops, sorry, it was a bit too quick. For Gusto. Then you get Azure Data Explorer. You can connect to the cluster. For the cluster, you will need to use the cluster URL, the database, but you don't have to. And then you can choose to go for import or direct query. You should always use direct query with Gusto. Sometimes it might be that in one of those tables you have trillions of rows, and you for sure don't want to import them. So Power BI is definitely possible. It's doable. It's nice and works nice and snappy with all of these queries in here. Something that you should take into consideration is that there's a new feature for Power BI. A new preview feature is called the dynamic M parameters. And what you will achieve with that those dynamic M parameters is that you push down parameters to the engine. So M parameters, so that you don't need to do some sort of a post filtering in Power BI. So it all tries to. The idea of those dynamic M parameters is to push down some of the query logic to the database, where it can be processed much more efficient and only return the necessary rows to Power BI. Yeah, reason being for that is that the humongous data amounts of data that our customers are using with Gusto and Power BI should push down those predicates. Okay, so yeah, this is Power BI. We covered that, and there are tons of other tools out there. Let me see what I wanted to cover now. Actually, we'll come back to those kinds of demos in later to do like more interesting stuff. But let's just finish a couple of the interesting parts of the slides. So what you've seen is KQL. KQL, it's a rich and query and powerful query language. You've seen some of the things, really small subsets. You will get more later. You saw some out-of-the-box visualization. It's an easy syntax plus IntelliSense, and this is also very important. In some scenarios, it might be that the operators are not, let's say, don't have enough functionality, because we've never come across a certain use case or a certain algorithm, and then you probably want to extend it. You want to extend the query language itself. You can do that by embedding Python code into the language. I think I will go there directly. I have an example prepared. So for example, Python in KQL, you see here there's a simple evaluate Python operator. Meanwhile, we improved the authoring a little bit. So right now we don't have to do all of these quoting line by line. And you can add your own Python code in here. You get pandas data frames as an input. You can return pandas data frames, and then do whatever you like in here. This one is a bit more specific. I think it's calculating some rolling average over a time series. Yes, you can use your own libraries. Excellent question, Sasha. You can use your own libraries, reference your own libraries. That's possible. That's possible with Python. Yeah, and actually, a lot of customers are using that. For example, one use case of that is imagine you have a fleet of trucks which are sending error data, so error from their CAN log, for example, and you would like to find out if it's a real error. You want to make your error system a little bit more smart, your error detection system a little bit more smart. Then you can do some model training somewhere else, create a model, probably an Onyx-based model, and then provision it in Azure Data Explorer and use it to do inferencing on newly incoming data. So this is where folks are using the Python extension usually. Okay. Let's continue here. Okay, out of the box capabilities that you get is time series analysis. Time series analysis starts at a certain function called make series, where we're translating a row-based analytics into a vector-based analytics. This allows us to do things like forecasting, regression, anomaly detection, so some statistics-based analysis, because we are able to create out of a time series statistic measures on the seasonality, the trend, and the baseline. And by that, we can find out, for example, we can do a regression analysis or find anomalies. The distributed Python and R execution that I mentioned, you can embed it in your code. You can use Jupyter or Python notebook or Python with it. We have a Spark integration as well. Last but not least, maybe one thing that is also truly unique to Azure Data Explorer, it's the ability to do data sharing. Usually companies share data by either providing an API or by doing things like, I don't know, creating a CSV and throw it over the fence, doing something like that. But the problematic situation in all of these scenarios is that you, once you share the data, that you at some point you might not be 100% sure where's the single source of truth. And with Kusto, even more over, it's not about like single source of truth. It's also about the vast amounts of data. So if you have like I don't know, petabytes of data, or even a couple of terabytes, sharing that with somebody else can be quite challenging. And also sharing data in a way that that queries on that data don't affect your own performance of querying the data. So what we created is a leader and follower concept. So imagine you are a division in a company which is collecting a lot of data, and you're storing it in your own Azure Data Explorer cluster and multiple databases. So you ingest data, and you probably also have some query load on top of that. Under the hood, as I mentioned, all data is always stored in Azure Blob Storages. Now, if there's some other department, either an internal one or an external one, yes, so KQL supports joins. You can create a follower cluster, which is a dedicated Azure Data Explorer cluster. It can have the same SKU or a different SKU. SKU means like size of the cluster, small, big, lot of many nodes, not so many nodes. And then you create something like a symbolic link to the underlying blob storage. And without the need to copy the data to the follower, the users of the follower clusters can access the data. And the single source of truth will always be the Azure Blob Storage of the leader cluster. So it's an in-place data sharing. All of that can be implemented using another service in Azure, which is called Azure Data Share. Okay, let's go into some interesting stuff on some real data. I prepared a couple of demos. Probably we go and take a look at some Power BI logs first. This is like the bread and butter business of Kusto, is logs and telemetry data. Okay, so this is this is a cluster. It's somewhere in the US. There's a database called SQL BI, and now we're doing something here. Now I'm executing the first query, and what this is doing, it's showing the size of certain tables, the original size. This means the size of the data when it has been ingested, and the size of the data when it has been stored on the underlying storage accounts which our customers are built for. Okay, and then the compression ratio means how efficient was our compression algorithm. Now we see here the compression ratio of 7 that I mentioned before, that we're doing, that we are communicating on our Azure pricing calculator, is quite pessimistic. So here we achieved a compression ratio of 9. Those are logs. In here, those are counters in this table, and the counters they're a little bit better to compress, so you get a better compression ratio. I think those are also counters, but different one. Compression ratio of 35. That's definitely an outlier. So 14 and 9. This is something that we see quite often. Okay, let's have a look at this data. The data itself consists of timestamps, some more timestamps, some roles. This is, I think, Power BI data or SQL data. So you have some virtual machines in here, which are called roles. And then last but not least, you have some event text, which can be anything, just a simple log line or a stack trace, whatever. The amount of data that we have here is roughly 41 billion rows. And now the next query is just analyzing a single day in 2015, and it's doing a summarized count by the level. So the original amount of data was like 41 billion, and the results that consists of 800 million records. And everything that I executed here is calculated live, so there's no results at caching or something. And we did a group by the error levels. Now let's have a look at a certain error level and just take 10 of them. I think that's the error level or warning. What is it? Doesn't matter. And you see, you get things like an exception object, you get a stack trace in here of some SQL server errors and whatnot. And this is the base of the data that we use for the coming queries. Now this one should look familiar to you already, but now we're doing some string parsing. So we're taking that role in here, like GW role, GW role _2, and do some parsing. And we want to find the role type, which is the stuff before the underscore, and then whatever comes after that underscore, we are not interested in that. And then we do a summarized count by the role type that we just parsed and bin it by a timestamp on 10-minute bins and render that. And you see here for certain role types, we get certain counts and can look at it. Yeah, so sequences of data. We have a sequence operator. Wait a second. Here's Data Explorer sequence or scan. The operator is called scan, and it can be used for process mining. I'm just pasting it into the chat. So maybe in the meantime, we can have a look at it. Let's find some really frustrated user. And now we are going to do our first joins. Also look at the let statement. It lets you define certain expressions. So I'm defining the lookup input. Lookup input is taking a look at all data on a certain day and all client activities which are not some default client activity ID. And then I'm filtering on a certain event text, and I'm joining it with the same data set with errors that we have and summarize by client activity, and then we're joining by client activity ID. This will allow us to get the most frustrated users. Again, like 41 billion, and we now found a very, very frustrated user, which is this one. Let's have a look at this error distribution from this client. So again, we filter for that user, do a join, and find out what's actually his problem and render a bar chart from that. And then we find that he gets a lot of exception on database does not exist, communication Frankfurt transport exception. So probably that user had a problem with his configuration of the database. Might have been already gone. Of course, we can also take a look at some of those some of those specific flows by looking at it based on time, and then see what happens for a certain activity. The next one is taking a look on counters, I think so. So I think those are CPU counters or specific counters. Here we have a CLR counter. What is that? Total number of transactions counter. And I think we want to have here, let's see what we'll get. We want to have counters in a certain time span, get the instances of those counters, and then see, get their average CPU by a certain role instance. So this already takes a little bit longer, might be thing which is more difficult. And then we see here, let me just quickly have a look at it. Should be all fine. We see here that there are a couple of roles which are using a certain, I think that's a CPU role, CPU counter, which is going up. And with this function, we can actually detect the jump shapes. So we define if from one point in time, a certain CPU for a certain role is value X, and the next timestamp it's value X plus 30% on top, then we say that this is a jump for example, in CPU. And now we're only interested in those roles which have those jump shapes. Let's execute it. We find that those roles are the responsible ones, and probably they had some problem while processing all of these queries. So what you see here is that you can do joins, you can do some time series analysis, and this is also true for other scenarios. I have one more demo on GitHub, but it's doing essentially the same thing. I think I would like to look on some geospatial data as well and some IoT data. But first, let's have a look at the same data in our dashboards, which I have not shown yet. So all of those kinds of queries can also be created in a dashboard. Okay, let's look at dashboards. I have one for log analysis. This is connecting to the same cluster. It's executing the same queries that I did before. So I have this arrow distribution. Then I have something for critical errors. So some statistics on critical errors by role type, doing the same stuff. And now can look, for example, for critical errors. Not that much in this data set. Let's look on warnings, probably be a little bit more. And you see it's also constantly changing. This one is, I could do now some text search in all warnings, because we actually we're also really good in text search because we're doing like n-grams of all of the strings. So this is what you can do here. Now let me also come this time from the dashboard area and then go to the queries eventually. So this is something that I'm using a lot. Oh no, not this one. Let's take a look at this one. Okay, why is it not? Query did not return any results. Okay, so it seems that I have a problem with my home automation system. It seems that it's not sending events. Interesting. So let's have a look at the last 30 days. You see, I missed obviously some data starting from here, and I'm only interested in certain devices. All of these parameters, they are query based. So I'm here interested, for example, in something that's measuring temperature and a lot of things in the outside, and some is doing that for my living room. Now the data points that I'm interested in is just the temperature. So it's filtering the results on the temperature, and all of that are like generated live queries on the last 30 days. Let's increase the resolution because I want to show a couple of more points. And then you see that that this is showing a little bit like almost constant temperature in my living room, and this is temperature on the outside, actually on my roof. The red dots here are indications for anomalies. And if you look into the actual query by clicking on Explore Query, you learn a little bit about how to do anomaly detection. So again, it's like first filtering a bit on sensor data, and then it's entering the time series world. Let's have a look at the data before it enters the time series. It looks like a proper rows. Now the next operator, transforming those rows into a vector where you have for each and every element that you have here in the by statement. So what you're grouping for, you have two arrays, one for the values and one for the timestamps. They both have the same size. And you also see here that in this time that the values, they have like empty values in between, which are shown as nulls. This is something that happens a lot when it comes to time series analysis, that you get a lot of null values. Now, you also need to have a strategy on how to fill them up. We support several strategies. One of them is doing a linear fill. So the gaps between 22.3 and 22.6 will be filled linearly. This is done with this statement. You see it's like 22.45. And last but not least, I can take now that complete time series and just execute a function to decompose anomalies. And what I get is another array, something like a bit field, which is showing for each and every anomaly a 1 or a -1. There were a couple of anomalies. Okay, here are some positive anomalies in the data set. And all of that is pretty straightforward without the need to invest in training your own model. You can do it with built-in capabilities. But I really should look after my setup at home. I'm a bit worried about not getting data. Yeah, so those are the things that I actually wanted to show to you. Let's see what I still have left in the slides. Yeah, okay. Let's talk about some burning topics. So questions that you always get. Synapse. I guess most of you know about Synapse. That's the Microsoft Analytics offering since November last year. We are part of Azure Synapse. This is underlying Microsoft strategy that Kusto is super important for Microsoft and also for all of our customers. We are now the third engine in Synapse next to Spark and SQL. And so far there was like for Synapse, the capabilities were limited, quote unquote, for modern data warehouse scenarios, and now it's extended for log and telemetry data. So sometimes customers are confused, and sometimes Microsoft folks are confused as well. So I try to do some clarification on what is Azure Data Explorer, and what's the difference between Azure Data Explorer and Synapse Data Explorer. What you need to know at the core of it, it's Kusto. That's the engine. And Kusto has been deployed in various products. One product is Azure Data Explorer in 2019 and Synapse Data Explorer in 2021, where Synapse Data Explorer gets received a lot more like integration love into Synapse and have the possibility to do like low friction interaction with other Synapse engines. And they're going to be more soon. How to become an ADX expert. We have a couple of documentations, of course, documentation websites, white papers, blogs, reference architectures. We have all of that. We have also a lot of social channels. I think our YouTube channel is pretty good. We have a lot of online courses, which you can use. Also like a Pluralsight course, an MS Learn course, very simple and very nice. There are going to be micro hacks soon as well. If you're interested in joining our partner program, we're always searching for implementation partners. We have so many projects, and we need help on finding the right partners for our projects. And we also support our partners a lot. For example, we have partner programs for AMD-powered deployments. And so there's a triple AP ESIC program which I created a link for here. If you like to run a POC with Azure Data Explorer and it has a well-defined scope and so on and so forth, you can ask for getting a free POC. Free POC means you deploy Azure Data Explorer in your subscription or in your customer subscription and return off the billing flag for some period in time. We also offer training, upskilling, and so on for our partners. And by that, I would say it's pretty much like 1.5 hours. Yeah, feel free to ask questions or reach out to me on social channels or via email. Yeah, happy to answer them.
Thank you, Henning.
Welcome.
Any more questions, guys?
Great stuff. Okay, thanks, Vinay. You also need to try it. You need to go. You need to learn KQL. How do you want us to call it in the future? Okay, if you like, okay, call it Custo. If you talk with somebody from the product group, always call it Custo, because we don't like the names that we've been given. There has been some, I know, some Uber logic in the Microsoft marketing department, which decided to call it Azure Data Explorer, which is probably the worst name for the product on the planet. I think anything is better than that name. So Custo is really, really good. So if you call it Custo, you will have immediate friends in the product group.